Now that we know a little bit about Git, what is GitHub? GitHub is a website. GitHub also happens to have users. And users have repositories, or in our very simplified version, a folder with a .git folder inside of it. In general, we can think of each user as having its own private or public repositories. Private repositories can be shared with specified members, whereas public are open for anyone to view at any time. One of the commands we haven't quite discussed is git clone. What git clone does is it allows you to copy someone's repo from GitHub or any other hosting website and copy all of that information, all of the branches, versions to your local computer. We'll go through this one in detail, and then I'm just going to show a screenshot for creating a new repository. One, it's very simple, and two, you won't have to do it very often. But in GitHub, you'll see a new repo button. Click it, give it a name, select public or private. There are a few other options that you don't necessarily need for this level tutorial. And then clicking the create button will create you a nice empty folder in GitHub. So a few days ago, I created BobTheDragonFighter, and I made some commits, added our chapters, and now we have a full story very similar to the one we left off with. So in our folders, I've gone ahead and deleted the one we created locally, and I'm going to download the new one. Git clone, and now it wants to know, what do you want to clone? If you go to the website, and they have a little drop down here, handy dandy copy button. All you have to do is paste that in after the git clone command, right click paste, press enter, and now if you do an ls, which I have no idea what that stands for, I always thought about it as look-see. That's not what it stands for, but you know, whatever. Anyhow, you'll notice we have our Bob the Dragon Fighter folder and our 5 chapters. A couple of things to notice here. If I do a git log from the actual folder, you'll see I now have a branch, so it recognizes this folder is a Git repository. And if I do a git log, you can actually see that I have a whole commit history of one commit. So it looks like I did all of this in one step. Not ideal for the video, but is what it is. So let's go ahead and close out of this. Whoops. And I'm going to go back here, delete this, and create a brand new folder again. Bob the Dragon Fighter. We're going to call this 2 just to signify that they are different. So I'm going to just clone the code one more time, keep my URL copied, and click New Tab, clone, paste in the URL, browse to the correct path where we want it, right there. This is the root folder. They match. Click clone. And now, as you can see, we go back to our folder view, and I'm in this folder, and I have my 5 chapters. Awesome. Now that we have a GitHub repo, our changes aren't only for us. So let's go ahead and create a new branch called update chapter 1. And that's what we're going to do. We're going to update our chapter 1. Maybe. Open folder. Tutorials. That one right there. Okay, so we want to update chapter 1. All I want to do is correct the line there, and we'll make a commit. Now that this has been committed, I want to actually share this with everyone that has this repository, how great a change I've made. No one right now can see that unless they're on my computer, and that's really not great for sharing. And so Git has a push command. So I'll do a push, and you'll see that it's asking me if I want to push the master branch or the chapter 1. And what I want to do is I want to push chapter 1. Notice that the remote branch for this is empty. The remote literally means the GitHub repository branch. They can be named differently. Generally speaking, people sync them up and never stray from that. I don't know why you would, but it is an option. So whenever I checkmark this, it will automatically fill out, hey, you probably want to name the one that's going in GitHub exactly what it is on your local copy. So it's very important to remember, adding or staging and committing are local actions. They happen locally. You can do them in GitHub, but generally speaking, when you do a commit, they are local. So in order to share this information with anybody, you need to push it to the online repo. Generally speaking, it's going to be like Bitbucket or GitHub, but in our case, it is GitHub. So I'm going to do a push, and I'll show you how to do this in command line in just a minute. But if we go to GitHub, we already notice a little message. Update chapter 1 has recent pushes less than a minute ago. Okay, great. What is this? This is what we call a pull request. Not sure I really like the terminology because it kind of gets confused with what an actual pull is, but in general, they're slightly different. So let's do this. If we click compare and create a pull request, whatever that is, you'll see that it asks me one question and some fields. This is the major part, and it is asking what branch do we want to merge these changes into. The only real difference between a merge and a pull request is merging is the action of doing it, and a pull request is like, hey, would this be a good idea to merge? So then other people can review it, look at it, make changes, do whatever, send feedback, and then more iterations can be done, and then eventually it can be merged. So in my mind, I'm not sure why this isn't called a merge request, but I didn't make any of this. Maybe someone that understands it more than I do could tell you. So we can now scroll down and see that this pull request would contain one change. It looks like this file had one line, now it has two, and that's about it. So I'm going to go ahead and create the pull request. And now in GitHub, you will see that there's one pull request. If I click on it, you'll basically see the exact same screen. It'll tell you some gobbledygook. For now, just know that you could merge this if you wanted to. Or you can go here and actually view this. In general, someone will make a pull request, another developer will review it, and then either that developer that created it, once it's approved, or perhaps someone else will go ahead and actually do the merge. So for now, I'm going to just show you the menu. The tooltip here is very helpful, and it tells us you can't pull your own, or you can't approve your own pull request, which seems fair. But if I wanted to, I could leave comments in general, or I can click here and say, why would Bob wake up? And we can start a whole review. I can just add a comment like, it's probably not necessary, but whatever, or I can cancel. I'm going to go ahead and cancel. Once I'm done with this, someone else would sign off, and then eventually whoever is in charge of this is going to click the merge button. And now it is merged. So let's go back to source tree. And I want to also go back to GitHub. So I'm to CLI as well. So We are on the update chapter 1 branch. We're done with it, and we're going to go back to the master branch. So right now in GitHub, if we look at the master branch, because this was merged on GitHub, if we go back to the code, we go to chapter 1, one thing to take note is that was my last commit message. This tells us what messages were applied the last time that file was changed. This is why it's good to have a nice commit message and nothing as vague as init or updates. And trying to keep your commits smaller rather than larger is super helpful, because if you change dozens of files with one message, it's kind of hard to tell what you're doing unless you're literally renaming something, and then it's pretty self-explanatory. But in this situation, we're looking at the master branch. You can see this up here, and if I actually click on this file, I can view it. Notice that there are 2 lines. This is great. In the online repo inside of GitHub in their cloud, we have 2 lines, which is what we wanted. But if I look locally, I still have 1 line. But wait, I'm on the master branch. What's wrong? This is why we have the fetch command. Fetch is nothing more. It really doesn't change any of your current files. It makes no changes to the repo, to your important data. It only makes changes to kind of what's hidden behind the scenes. All fetch does is say, hey, GitHub, I was last updated on November 3rd at 3 p.m. and I have these commits. What have I missed now that it's November 8th or whatever the new date is? And GitHub is going to reply. So let's go ahead and do a fetch. Press OK. If we wanted to do that in terminal, it's pretty simple. Git fetch, and we can do it all day. It's not going to hurt anything. But you'll notice now there's a 2 here. And if I type in a git status, you'll notice that your branch is behind master, which means that there are 2 commits sitting inside of GitHub that we don't have on our local copy, because everything here is local. So all I have to do is a pull, and I will have those changes. Or I could also have clicked pull here. Now once the UI updates, sometimes I just do a fetch to update it. For some reason, the UI updates don't always grab these, so sometimes just clicking fetch is nice to get the pull and push numbers corrected. Otherwise, sometimes it can be outdated for quite a while. But anyway, if you go over here and do a git status and a git fetch and everything, you never really have to worry about that. So something to think about. Now though, if we go back to our file, as promised, we have our 2 lines locally. We are now completely synced up on the master branch with everything else we wanted to do, which is just great. Now that we have our repo online, someone else has made a change or a suggestion. If we refresh this, we'll see that a new branch from Summer has been deployed. So let's go ahead and create a pull request. They want to merge this into the master branch, and let's take a look at the difference. So they've already created this, pretend that already happened, and now we're looking at it for the first time. There's no conflicts, that's a great thing. We haven't really talked about conflicts with GitHub. It's the same thing as local. So it looks like Summer wants to change chapter 1 and 5. She wants to kind of reword these and change some stuff here. Okay, sounds great. I'm not certain these are the changes I want, and whoever approves these just hasn't looked at it yet. So the question becomes now, how do I see them locally? Well, let's try a git fetch. Let's just try that out. Okay, well, that didn't work because my branches here are just the local ones. So how do I get a remote branch? If you check down here and expand, you will see, Summer's suggestions. This should be synced up totally with whatever is inside of GitHub. So if I do a git branch, this is going to show me the local branches. As you can see here, it is the exact same as this. If I do a git branch -r for remote, you will see that we actually have all of the rest of them. So these are the branches that are in GitHub. So we can do quite a few things here. We can check out Summer's suggestions on our own local computer, and then we would be able to add to her pull request by simply making a commit and then pushing. Or we could merge her changes into another branch. Let's do the first one, and then we'll do the second. So what I want to do now is I want to check out this branch that is only remote. I can do this by a simple double click, and it will ask me if I want to track the remote. And what that means is, if you remember earlier, it said, hey, your master branch is 2 commits behind the repo's master branch. Do you want to pull those in? That will allow that same thing to happen between the origin branch or the GitHub branch and the local one. So in general, you just want to leave that checked and click OK. That will create a branch locally called Summer's Suggestions, and it will check it out. Now, I don't want to do that because I want to do it in the command line. It's very simple to do, but clicking OK would have done it the same. So if I just Summer's Suggestions. Now, because I've fetched, Git knows about this. It understands what it wants to do, and it sets it up to track that remote branch exactly as if I had done it the other way. So if I click here and give this just a moment to update, you will see that we are now on that branch. And if I do a git log -1, or however many I want to go back, just ones right now, you will see that we have the commit. Again, I made this, but usually the author would be someone else if you're pulling a remote branch down, but I didn't really feel like setting up another Git account. But anyway, this is going to tell you who authored that commit, when it was authored, and what the message was. So that's great. We have this commit from Summer, aka me, just doing this locally, whatever. But now, here we are. We can now see that this chapter has been changed. The text here is different. The text here is different. We have that, dash, a dragon on the end. And if we look at the pull request that was created and refresh it, we still have those changes. You can see the diff. So let's do something fun. What I want to do now is I want to add, actually I want to subtract from this because this one's getting too long. So Archer sees this and he provides a rope. Yeah. Then he decides to fly them around the city and hope that they'll come back. Okay, great. Much shorter, concise. I like it. If we do a git status, same thing as usual. Git add. I'll do a splat this time. Why not? Git commit. All we're going to do is shorten chapter 5. That's what we did here. So if we go over here and we do a fetch, I didn't have to do that, but again, it never hurts. We will see that we're only ahead 1 commit. This means that the online repo is 1 commit behind what our local repository is. So all we need to do is push it. We'll make that push. Now it's done. I could have done the same thing with a git push there. Everything was already up to date, so nothing happened, but same thing. Notice the refresh icon. Let's click. What that means is that a push is automatically adding to this pull request, because a pull request is not a specific commit. It is the branch and all of its additional commits onto another one. So if we go ahead and well, I can't approve it, but if it was approved, then somebody could merge this in. And once again, if we go here or have source tree up, we would do a fetch because we're diligent, and we see that we're behind a few commits. Git fetch, either way. Git status, I'm doing just fine. If I check out master, it will already tell me, because I've done a fetch, that, hey, you're behind. So we just need to do a pull, and we can do it very simply like this. It's interesting. There it goes. It hadn't updated. But yeah, so pull from the origin, which is this website here, our Git, and what branch do you want to pull, and what branch do you want to pull it into? Okay, well, pretty simple. Click pull and it would work just fine. Or I can do it here. Not a problem either way. So I want to do one other thing just to show a little bit of what Git can do. Let's go back to this update chapter 1 branch. If I was still working on chapter 1, but I really liked Summer's suggestions and wanted that code to be part of my update, I can right-click this one and merge it. It's going to call pull, and it's going to pull those commits into my local branch, even though they're not the same branch. It's totally fine. Git's just going to take the commits and try to apply them on top of this. If there are conflicts, it'll let you know. So let's do it. And now you can see that we have added more commits to update chapter 1. And if we do a git log, you will see that it has our two most recent ones, the updates from summer and then shortening chapter 5, which is just great. These, when we pull down, it's always going to grab the latest version of that branch that is on GitHub. If Summer makes another change, another commit, for example, and we try to do that this way, it's only going to grab the commits that are local, because these reflect what is on your local computer, whereas these will always go out and grab the latest stuff from GitHub. So I hope that makes sense, because it's very important to understand where the data is coming from and where it's going. So let's talk just a little bit about switching branches. I've made a change and I've committed it to chapter 2. All I've done is basically added a new line. If I go and I check out another chapter or another branch, notice that I'm back to 2 lines. I want to change this sentence now. So Lily, Bob's friend, may want to help. I want to change that sentence. So I'm not quite ready to commit this, or maybe I actually wanted to do this on a different branch. As we've seen before, we can simply check that branch out. So let's do that. And we get an error. Why did we get an error? The reason, and I will show this visually for you in just a moment. The reason is that the file chapter 2 on this branch, update chapter 1, which that's not misleading at all, is it? Either way, the file here and the file in master are different. So let's take a look at what master looks like. I'm just going to push all the changes and we will go over to our branch. Make sure I get the latest. Cool. So if we notice, the chapter 2 is 2 lines. But in here, it's a single line even without my changes. So let's stash it and view that real fast. So this is how it looks. Will surely help him. And if I reapply my changes, we've reworded it, but master looks different. So when I try to check out, we basically have a merge conflict. Git says, well, hey, I don't know how to just switch branches here because, you know, the starting place for your current branch was this. The actual branch in master looks like this, and I don't know what you actually want it to be. Okay, that's not a problem. We can stash it. Git stash. Great. Now I can check out master. Oh, hey, look, it works. But I actually do want to apply those changes to master. What do I do? Well, you can still pop. And it basically creates a merge conflict. The only difference is that you're not merging commits or branches, you're really just merging some changes. So we've seen this menu before. We basically want to keep the incoming change and some of the outgoing. So I'm going to elect to keep the incoming, and then I'm just going to manually fix that I want this on 2 lines. I'm going to save it, and then if we do a status, I have an uncommitted change. Updating chapter 2. I don't know, Bob stuff. Cool. I do a git push origin or git push. They're basically the same right now. Doesn't the scope of what origin is a little bit beyond what I need to say. Basically, origin is a pointer to this website. So now we see the last time this was updated was 10 seconds ago, and there's my commit. This is awesome. The last thing I really want to cover, just some odds and ends about Git and just how great it is. Right now we're in the master branch, or we're viewing it. If I were to click a file, there's a history button up here. You can actually go through and view the entire repository at this point in history, or you can view just this file at that point in history, both of which are extremely helpful. Or you can do the same thing for a branch. Hey, I just want to view this branch, every file in it, only on that branch. And you can do the same thing. You can also click commits here, and you can kind of review these commits and what they changed and how they were done. So, you know, all of this is great information when you're trying to figure out when a bug was introduced, or, hey, you know, this report was generated at this time on this date. What was the code doing at that point? Because it's not doing it anymore. Where did it go wrong? All of these things are extremely helpful, and the greatest part is you can worry a lot less about your data, because even if I come into my handy dandy folder and I just delete this like I've done several times, a quick git clone and everything's back. The only thing that would be lost is anything I did not push locally up into the GitHub repository, which brings me to one other point. Commits are free, pushes are cheap. Commit and push often. No one's going to be upset about a couple of commits. No one's going to be, you know, very sad if you drop your laptop and don't lose any work. So, you know, keep that in mind. Although maybe you'd be sad because you lost your laptop, but, you know, a little